Hello students, today we are going to discuss about superconductivity, which is the part of fourth unit, that is condensed matter physics. To understand what is superconductivity, one should have the basic knowledge of electrical conductivity. We all know that if a conducting material of length L, area of cross section A, is applied with the potential difference V, then I amount of current flows in the current. And by Ohm's law, we know that V is directly proportional to I, or V is equals to R into I, where R is known as the resistance. The resistance is the internal property of the material to oppose the flow of the electric current. And clearly we know that R is always proportional to the length of the conductor, and R is inversely proportional to the area of cross section. Therefore, R is directly proportional to L by A, or which implies R equals to rho into L divided by A, where rho is known as resistivity, and this is given by the formula R into A divided by L. Resistivity of the material is capacity of a particular length and area of a material to oppose the flow of the current. Okay, now we know that this resistance of a metal is also proportional to the temperature. As temperature increases, resistance increases, which implies that resistivity is also proportional to the temperature. If we try to plot the graph of resistivity versus the temperature by taking temperature along x-axis and resistivity along y-axis, resistivity increases with temperature, something like this. Now, this total resistivity is sum of two types of resistivities. One is the intrinsic resistivity, which is due to the internal atomic resistivity of the material, plus it is the resistivity due to impurities in the material. So this is known as residual resistivity, that is rho naught, and this is the intrinsic resistivity, I can write it as rho IR. So this part of the resistivity, this part, though the temperature is 0, this resistivity is appearing, and this is nothing but the residual resistivity, or the resistivity due to the impurities. Now, if we take a pure conducting material, pure conducting material means the resistivity due to impurities is 0. So this material will be having only the resistivity due to the material itself. So this was first studied by Kemmerling-Onnes while studying the dependence of resistivity onto the temperature. So accidentally he conducts an experiment to understand the dependence of rho and T in case of a pure conducting material, that is nothing but a mercury. All of us, we know that mercury is a conducting material which can be found in its purest form. So this material was taken for the experimentation and the temperature was changed experimentally and resistivity was noted for different temperatures. As the temperature in this case was reduced at a particular temperature, the resistivity completely turns to zero. This property of the material is known as superconductivity. Hence, superconductivity is a phenomena and in which the resistivity of a material goes to zero at the lowest temperatures. So this lowest temperature is very important in case of superconductivity. It is known as critical temperature. So it is denoted always as Tc. So this is the Tc. So when Kemmerling-Onnes was observing the dependence of resistivity on the temperature in case of mercury, he finds that the mercury at a temperature of 4.2 Kelvin turns into a superconducting material. That is, its resistivity completely goes to zero. Hence, the material is known as superconducting material, or material is in its superconducting state. After this, the phenomena of superconductivity was studied by many others with different types of material at different critical temperature. So by this discussion, we understand two important things. One is what is known by the superconductivity phenomena and what is meant by critical temperature. I repeat once again, superconductivity is a phenomena at which material shows resistivity as zero at the lowest possible temperature, and the critical temperature is the lowest temperature of a particular conducting material at which its resistivity goes to zero. Thank you.